The idea for the Morphing Wing aircraft came from just looking at new ideas in aerospace as a whole. And one sector that interests me the most was morphing aircraft. When thinking of ideas for the project, I wanted to do something that hasn't been done before or hasn't been heavily researched. So you can take a jet engine and you can change little parameters about it and try to make it perform better, but you're not going to reinvent the wheel. A jet engine is a jet engine. However, with morphing aircraft, there's so much you can do with so many new technologies that allow you to really create an original idea.
So for Morphing Wing, we tried to do three things. We tried to create a plane that could fly higher, fly for longer, and also fly faster than any other UAV that's fixed wing. So by having a Morphing Wing, essentially we were able to do the job of two different fixed wing aircrafts, being able to take off in a shorter distance, to be able to have a higher climb rate. So once we reach altitude, we were able to retract our wings and move at faster speeds to go from point A to point B until we went over our LZ. Once we were there, we'd extend our wings and surveillance, flyby, glide for a period of time, retract our wings, and quickly leave whatever area we were doing surveillance in.
For morphing wing aircraft, we will have a wing that is able to extend the wing area. The goal of doing it is to increase the efficiency of the aircraft. So for the first step, we estimate that the total weight of the aircraft will be around like 7.5 kilograms. After lift required on the wing part is found, we will need to find out the lift on the tail part. The way we find out the lift on the tail part is to understand and find the equilibrium relation between them so that we can find out the tail sizing required that is able to balance out the moment on the wing part and the tail part.
Among the many technical findings that we have found in the X-Plane simulator, one of the most important one was the extending capabilities. Me and an electronic engineer, Chen Ming, were able to install extending and retracting morphing capability in the simulator that we have developed to see the change mid-air, on the ground or anywhere by pressing a button to extend and retract. And our mechanism makes it so as it can extend at the same time. So the simulator were also able to show that, and we were able to get data that are going to be helpful for us in the extending, retracted, and conventional ways.
I was interested in RC planes before the project, and now incorporating what I learned from other hobbies into the project, I have used a picksock with some compatible sensors such as accelerometer, GPS, gyroscopes, barometer, etc. And those are general setups for RC planes, incorporating with some motors and propellers. But to be specific, designed for our project, we have done power calculation and battery calculation just to make sure that we have enough endurance and enough power.
We worked with structures to try and figure out how we would power the mechanism that they designed. We decided that we would use a NEMA 23 stepper motor that would be suspended below the mechanism to actually extend and retract the wing.
We put a gear in the center, attached that gear to a shaft, and that shaft to two threaded rods, one left hand, one right hand, and we put a nut in the moving wing. And so as that gear was turned, the threaded rods would turn opposite directions and it would push or pull the wings in and out. So the ribs in our wing come about every 200 millimeters, and each rib has a rib cap, and a bearing surface. And the bearing surface is what the moving wing slides on.
One of the unique aspects of this project was working with PVA, which is a water-soluble 3D print filament, and we were able to use that to create a male mold for the static wing to make the composite. The findings for the composite was looking at the different weaves of twill weave, unilateral, multilateral, from carbon fiber to fiberglass to overlaying both of them towards the end.
Looking at all different applications for this project, whether it be military, law enforcement, or civilian uses. Specifically with the military, being an RTC cadet, I discussed a lot with some of my cadre members about what benefit a morphing wing aircraft could bring to the military. One thing that stuck out is the military's shift towards multi-domain operations. So what that means is we're looking at multi-dimensional battle space with multiple changing factors. What a morphing wing aircraft allows us to do is change the aircraft's abilities to meet those performance parameters that are needed adapted for different mission sets. And I think that's something that's very unique to this project and the abilities of this aircraft.